This is the AMBER summer camp. We're going to start in a minute after Cesar has finished. And I think he has already finished. A nice way to start the morning on Monday. Welcome everybody. This is our AMBER summer camp. We have 5 sessions where we will go in more depth about results from AMBER, the project about adaptive management of barriers in European rivers. Welcome everybody. We'll have 2 speakers today, Barbara Belletti and Josh Jones, and they're both going to talk about the inventory of barriers that we had in European rivers. and estimation of fragmentation. How is it going with the fragmentations of our European rivers? Before I start, I'm always eager to find out who is listening. So I have prepared a poll here, and I'm curious where you guys, who is the audience, who is actually watching at the moment. You can see the poll now in your screen, I think, and you can click on the button. Are you a researcher or a policymaker? Or are you from the industry, from an NGO? And people are responding at the moment, and I can see most people are from the academic side, but also NGOs, also from industry, other. I will show the main results. I think most people have answered now, or half of them. Okay, so most are researchers. Well, then we know who are you talking to. Thank you very much. I will share my screen for a moment, because just to point out how we're going to do this today. The summer camp is set up as a normal webinar. You are in a view and listen mode only. If you have questions, you can do that via the Q&A button that's on the bottom of your screen, or you can talk via the chat. Now, we are with a very limited group, about 30 people. So what we can also do, if you want to be more active involved, let's raise your hand, and we will get you into the video, and you can talk and just participate more, because we are such a small group that is possible. The summer camp program is as follows. Today, in this morning, we have the barrier inventory and estimation of fragmentation. This afternoon, we will talk about decision support tools and prioritization. And tomorrow, we will talking about the rapid barrier assessment for fish habitats. We will talk about in the afternoon in telemetry of rapid barrier assessments. And on Wednesday in the morning, we will talking about the barrier tracker and how the future will be from barrier tracker. So for now, I would like to introduce Barbara Belletti. Barbara is Italian from origin, now living in France, and she works on the whole barrier inventory from the start, from the barrier, from the atlas that Amber has been working on. And she's going to tell us about it, how it was set up, the whole barrier inventory, and how we came to the product that we have now. Barbara, can you start your presentation and tell us more about the setup? Your microphone is still off, so you can put that on.
Yeah, it's on now.
Yes, thank you.
Okay, so morning, everyone. Thanks, Ariane, for this introduction. As Ariane said, today we are going to, this morning with me, we are going to see a little bit the backstage of the AMBER Atlas building. We started with too many problems to solve within AMBER. It was part of AMBER. The fact that river fragmentation is caused by many barrier types, and the fact that river fragmentation in Europe, the extent of river fragmentation in Europe was unknown, but we knew that many inventories existed at different levels in Europe. So how we solved this? First of all, we had to define what we are talking about. I mean, in a river system, there are two kinds of barriers. There are natural barriers such as cascade, pool river system, step pool system, and the rivers are used to these kind of barriers. And then there are man-made barriers that men have built since 2 centuries ago and even before. And so AMBER mainly focused on such structure, not on natural barriers, but on man-made barriers. And which is the impact of man-made river barriers? We know that barriers may impact sediment and flow regimes, but also movement for organisms, water quality, and then services. We know that larger structures such as dams for sure impact water flow, but we know also that small structure maybe that not a big impact on flow regimes, but have a big impact on all the other components. This picture is from the Rhone Water Agency. I think it's very, very, very nice to explain this. So you have a small weir and a small weir that is trapping the sediment upstream, and through times this cause a deficit in sediment in the upstream part, causing then incision and narrowing, then a groundwater levering, and a possible disconnection between the river channel itself and its floodplain. So with consequence on habitat loss, not only in the channel itself, but also in the floodplain. And then this also is an issue for biota, because there is not only a problem of migration routes that are disrupted, but also a problem of habitat loss. And this deficit incision can also cause destabilization to human structure. So the impact of man-made river barriers are really, really important. And so this allows me to come back again to one of the AMBER key messages that Wouter presented in the webinar 2 weeks ago. So for AMBER, all barrier matters, because it is not all important to see the impact of few large dams that we have on our river, but we have to recognize the more widespread, the cumulative impact of hundreds of thousands of small structures on sediment transport, fauna, and nutrient quality that are widespread everywhere in Europe. So, first point, what are we talking about? We are talking about man-made river barriers, and the definition we have provided is man-made barriers are all the structures that are built by humans, interrupt or modify the flow of water, the transfer of sediment, and the movement of organisms, and that can result in longitudinal discontinuities. So now we have seen what is the broad. We are going to go a little bit in the detail of the barrier types we have included in our atlas. The first type is offshore, of course, is concerned dams. So, but dams are structures that blocks or constrain the flow of water and raises the water level, generally forming a reservoir. The uses of dams are many. So dams are used for water supply, generation of electricity, and they significantly impact the flow and the sediment regimes because they intercept completely the bedlock, and they can cause also a complete barrier for organisms. The second type of barrier we included in our atlas is weir. Weir are generally structured lower in height compared to dams, but they can reach also significant height, that is 10 meters. But the difference to dam is that where water always flows above freely over the top of weirs. Weirs there are many types of weirs in our rivers, and generally are used for regulating flow condition, or they can be used for water diversion, for intercepting sediment and stabilizing the channel bed, and so reducing the channel slope. The impact of this weir is really significant. They can alter the water flow depending on their height, more or less, but the impact on sediment regime and of movement of organisms is significant. A third type we included in our atlas is sluices. Sluices are movable barriers, often are found in low land rivers. They are used to control the water levels and flow rate. They can also allow navigation through rivers. And they have more or less the same impact as weir, but the impact is discontinuous. So it's depending where the gates are closed or not. But we also have sometimes where sluices are in combination with other barriers. So we can find, for instance, weir with a sluice gate in our rivers. Another type we have included, so now we are moving a little bit toward low head structure. So we have culverts. Culverts are really, really everywhere in our rivers. Are structures that are generally used to carrying a stream or a river under an obstruction, so allowing road crossing. And so they have many shapes with different size, and the impact of this structure is mainly on habitat modification. Habitat modification locally in terms of physical terms, but also in terms of, for instance, in terms of temperature, because they create a discontinuity in the river, in the streams. Another type of barrier is ford. Ford are again low-edge structure which create a shallow place for crossing the river by stream or the streamer by wading. These structure again are causing a habitat modification locally, but also upstream and downstream. And also since they stabilize a bit the channel bed, they can cause an alteration of river dynamics. I found that picture in the bottom picture is from Ohio in the US, just to show you that these kind of structure are probably really, really old. So we started to build this structure centuries ago. Another type is a ramp of bed seal. We put them together because they have the same purpose, more or less, that is of stabilizing the channel bed and reducing erosion. So once again, these are very low head, generally underwater structure, and they cause an alteration of habitats locally, and since they block the channel bed, they cause an alteration of the river dynamics. In many mountain areas, we can find often a succession of many of these structures to stabilize the channel beds. And then the final type we included in our atlas. So we decided to also include other kind of barriers that probably are not complete barrier, as for instance lateral groins or flow deviation structure, but they anyway they have an effect, an impact on the sediments, on habitat modification, water flow, and so they generally alter the natural functioning of rivers. There is also the picture on the top left is probably for blocking the wood, the vegetation that flow through the rivers. So this is again an impact on river flow. So now that we have seen all the barrier types that we decided to include in our atlas, let's see how we deal with the problem of river fragmentation. Why we decided to build this atlas. Wouter 2 weeks ago already showed that slide. The problem was that the knowledge of river fragmentation in Europe mainly relied on the existing large-scale data sets that were very detailed on the distribution and on the number of dams that were on European rivers. From these inventories, we can count about 5,000 of large dams in our rivers. But we quickly understood that it was only a small part of the cake. And so one of the main scope of AMBER was to find out where all the other small barriers that are present in our rivers are located. To do that, so we decided to build this atlas. We have seen at the beginning of this presentation that we decided to concentrate, to focus on all barriers because all barriers matter for river continuity issues. We build our atlas combining all existing institutional database that we were able to collect, and we found a way to homogenize all this information together to get the barrier atlas. First problem, finding all existing institutional data set is not an easy task because existing institutional data set differ a lot among them. We can have some cases where we have very detailed and consistent database, as in France, where they are already do a job trying to homogenize all the information they had in at the national level. But then, for instance, in Italy, where I'm from, at the national scale, we only have a database on main dams, whereas there are other detailed data sets at regional scale that are sometimes available on the web. Sometimes we have to ask for them, but it's not, I mean, the information is scattered and is not easy accessible and is not consistent at the national level. Another example, on the right, there is the Balkan and Danube region, where again, here we have sometimes data sets are accessible only at the national level. In other cases, we only have a database accessible at the regional level, as for the International Commission on the Danube River, or the recent Balkan River Initiative that collected data on this area. And sometimes we have both of them. So we had to deal with that. How we decided to do that? For instance, we looked at the information present in these data sets. And we found that in order to make things comparable and homogeneous, we had to focus only on few variables that we call the barrier identity card. The first variable, the first parameter is the Atlas ID. So we define for each entry that we upload in our Atlas, we defined a unique ID. Then we also thought that it was important to keep track of the relation with the existing data sets, the data set where we taken the data from. So where it is possible, we also include an ID of the source database, but for sure, at least we keep a link to the data source. So it would be, could be a web link or a database name. Another important part of our atlas is to identify where barriers are located. So for this, the variables that are describing these are mainly the country where the barriers are located, the geographic coordinates, and if possible, also we try to keep information on river and basin names. And then concerning the characterization of barrier and for assessing, helping us in assessing their impact, we decided to focus only on the 3 simple key variables as barrier type, as we've seen before. Just to let you know that when we collected all the data together, we had to face hundreds of different barrier types used across Europe. And we did a big effort, a big work, trying to homogenize and translating all these different barrier types into the 7 barrier types that I presented before. The second key parameter to assessing the barrier impact, the barrier characterization, is barrier height. Again, this is important to know the effect, the impact of one single barrier, but it is important to have this information. The problem is that this information is at the end available only for the 20% of the records that are in our atlas today. And finally, another important parameter that we thought was not trivial to have in our atlas, the year, so the date of the barrier building. This is important because barriers are often being built in the past, so they probably get old and maybe need to be restored or maintained. So this was an important variable. But the problem was that it was almost empty in all on the data set that we had. Beyond the barrier identity card, so this was the variable that was, we hoped was the most available. in the existing data set. But we then also we go beyond this and said that probably we also need some other information for at least that could be used for barrier reporting and monitoring in the future, and also for assessing barrier impact. These are, for instance, barrier width. This, for instance, is important when we deal with barriers such as groins or diversions. So it is important to know if the barrier is impacting completely or not rivers. But is also relevant for barriers that are getting old, because probably they are broken, they are damaged, so they are not yet, not anymore impacting the full extent of the river. Another important barrier that we think it is important for barrier monitoring and for assessing barrier impact is the presence of a fish pass. Fish pass simply allows fish movement and migration, so not considering other components, other biota elements, but it is still important to know if a sort of mitigation is present in the barrier. And then the third one is barrier use. Again, this relates to the fact that on the history of barriers. Many barriers are getting old in our rivers, are abandoned. So it is important to know, even for prioritizing future barrier management, to know if the barriers are still in use or not. These three last attributes that we consider important for assessing river fragmentation and for our inventory can be particularly assessed using the barrier tracker that you will see the presentation in 2 days. So, the second key message that Walter presented us 2 weeks ago, but many barriers are becoming obsolete, so they need to be prioritized in future barrier management. So once so the first step has been to combine all the data set together. We get our barrier inventory that is composed of 630,000 of records coming from 120 different databases and from 36 different countries. We have done a big effort to homogenize this data set, particularly to homogenize barrier types, and we selected a few key variables to be informed, to be displayed in our barrier AMBER inventory. But is that the end of the story? Not at all, because as I said before, these databases are different, being with different purposes. Sometimes there are many different databases for a same country, so we needed also to manage this issue. But you will see that in the Josh presentation just after the questions. And to end, I'm going to ask Arian to launch the pool. I'm going to I'm going to ask you to recognize different barrier types. So this is so you can what kind of barrier is this for you?
I'm not sure if people can see it. Yes, people can see it. There are some answers coming in right now. You can take the box of the questions a little bit further. Maybe some people don't see it. I realize that sometimes on Zoom people cannot see the polls, but at least there are people voting now. And most of them think it is a where, actually.
Okay, they are right. I agree.
Okay, well, let's go to the... Maybe we can go to the next one.
Yeah. This one.
Is that the next one? Yes.
Can you see that?
Yeah.
Ah, this is the answer.
And here, most people also think it is a weir. Only a weir or a ramp or other.
Okay.
Yeah. So, what is this?
This is a ramp, actually. So it is made of blocks that follow the river slope. They are underwater, and they are there to stabilize the riverbed.
And the third question, I think some people have already answered. That's a little bit confusing, maybe.
Yeah. Sorry, I had to present all the questions together. So this is the last question. Does the barrier extend across the entire watercourse?
In this picture?
In this picture.
Oh, no, the answers are changing now. And it's 50-50 so far. No, more people say no, actually. Yeah, that's increasing. More and more people are saying no.
Okay.
Yeah, that's very clear now. Oh, yeah, it's growing. Yeah.
Okay, yes, this is true. This barrier is not a complete barrier because, yeah, it is only a diversion. Okay. So the message is passed.
All right. Thanks very much. Okay, thank you. Maybe let's start first if there are some questions. If people want, you can also come in, so to say, we can see you. But if so, then raise your hand. You can raise your hand with Zoom and we will include you. There have been some questions, I guess, on the Q&A section. Sarah, you have been watching them. Maybe you can say what the questions are for Barbara.
Yes, we have a first question that was from Polona Pengal. She's asking, so this is a bit of a long question. There is a bit of an introduction, which I will read out loud. So we have loads and loads of barriers, like the one used for the pole, and these are declared as maintaining water level. This is also the main requirement from the National Water Authority. If you want to remove a dam, you need to maintain the water level. So why is maintaining the water level so crucial in all barriers?
This is a very huge question. So we are not talking about dam removal today. And the aim of AMBER was to spot where all the barriers are located, to assess which is the strength of the impact, and so to be more aware of what is happening in our rivers. Barriers, one of the messages of AMBER was also that barriers are also useful for humans. So they are providing a lot of ecosystem services. So it is not here a matter of removing all of them. What we would like to do is to assess which is the extent of the impact, where is room for improving river fragmentation, maximizing the benefit of river fragmentation without compromising the benefit of barriers to humans.
I have another question, because thank you for your presentation to begin with. I find it like a massive job what you try to do. I mean, this is a super challenging task. And to be honest, when I first learned about this, I was quite puzzled, and I thought this had already been done. And it's quite fantastic when we realize, no, this has never been done, and actually super challenging. So the question is, what was the main challenge for you to make the map? I don't think there is only one main, but it would be nice if you could share this with us.
I think that with colleagues from World Fish Migration Foundation, we can say that one challenge was to access the data. It was really, really a big challenge. because even if environmental data should be fair and easy accessible, they are not. And so it was really one of the biggest challenge through all the 4 years of AMBER.
It sounds like a big challenge in that one. And I also, given just the questions you did, showing the pictures, I think it must be also quite difficult to standardize what a weir is, what a ford is, and making sure that we got it right. I just wanted to highlight, we don't have any more questions. We are going, but I would like to, if anyone has a question, where you can raise this question is in the Q&A. Oh, I just said this and there's something else. So there is someone, Elena Longlin is saying, I might have missed it, so sorry if you've already answered this, but have you said you considered only old barriers in the atlas? This is the question.
Only old barriers?
Yes, I'm not sure if this...
No. We consider all existing barriers that are in our rivers. But we think that also knowing where the old ones are, it is important for future management.
But maybe Elena means if there are no new plant barriers.
Okay.
I guess.
We focused on existing barriers. So, and on barriers that are on building, not on planet ones, not for the atlas.
And maybe it is, I guess, another challenge you may have had is actually with all the barriers that you tried to record, maybe one of the challenges is actually knowing if they are being used at the moment, or if they are just, very old or not even in use. And I think that's one of the things that probably also, oh, there is another question. I'm making a bit of time, and as soon as I say something, someone asks a question. So this is another question. It's also from Elena, from who has just asked the question about the old barriers. So she's asking, is the database available? I'm going to actually send the link.
Yes.
You can send it in the chat. That would be useful.
Or maybe Roxanne could share the link to the database, which is now available to the entire atlas. And we will have it available to everyone on the chat. And the data has been available to download since last Monday. So yeah.
There's a download button on the map itself. Okay.
But, thank you. I was just going to say, I guess people are very eager to download this data and check the Berry Atlas now. But I guess, Arjen, you want to say that we may want to continue with this webinar and workshop, and maybe people can just check the Berry Atlas once we finish, I suppose.
Yes. Okay, let's continue with, thank you very much, Barbara. We continue with Josh Jones from Swansea University, and he will tell us more about the fragmentation. Josh, can you come in?
Hello.
Hello.
Here I am. We've got that?
Yeah. We
Excellent.
don't see you though.
Hang on. Okay.
Oh yeah, no, of course.
Okay. Good morning, everyone. So, leading on from Barbara's talk, I would like to tell you about what we're going to do with some of the information we've gathered and how we can, how we've managed to clean it up, and how we can get to a picture of fragmentation, because there's still a lot of work to do. So, in theory, we get our data, we've cleaned it up, and we have our river network in a GIS. And we have 100% confidence that all of the barriers we've collated into our database are present. So our picture is 100% correct. So all of those red points represent all of the barriers. We have one barrier database that is consistent. So all of the types are the same, and we have lots of height information and all the attributes we could wish for all of our barriers. And all of the points, importantly for estimating fragmentation, all align with the river network. So you can see in this image all of the red dots, which are the barriers, fall on the blue lines, which are the rivers. So if you want to use that data to estimate how fragmented that river is, your life has been made quite easy, because it's all the data fits nicely together. But in reality, it looks a bit more like this. This is somewhere in Switzerland. So you can see there's two different coloured dots. So these are barriers that have come from two different databases. So one of the things you might think is, well, are those blue dots and green dots which are overlapping each other, are they duplicates? Or are they all unique records? The blue line you can see is a river network. Although it's not the national Swiss river network, it is a river network that is consistent for the whole of Europe. And you get the similar ones, you can get hydrosheds for the entire globe. And so if you wanted to do a large-scale analysis, or your country doesn't have a detailed river network or a consistent one, you would have to use one of these consistent global river networks. So the other question is, are all of the barriers there? Do we know that we've got 100% of those structures? It looks like there's a lot in this image, but are there more, or are there less? Have some been removed? And which stream channel should these points be aligned with if we're going to calculate some fragmentation metrics? You can see that in this image, these barriers probably highlight where the streams are. But in some cases, particularly at the confluence, you don't know which barriers are on which part of the stream. And what about the barriers that are on streams that aren't represented in this map? What do we do with those ones? Do we just throw them away, or can we make use of them? So the first thing I'd like to tackle is duplicates. So when we combine lots of databases together, as we've done in the AMBER Atlas, there's lots of overlap. So that means that you get more than one point representing one structure. So you can easily see in this image, this is somewhere on the Danube, and you can see that both of these dams are represented in 3 different databases. So each different coloured point represents data from a different database. So if you just looked at this image, so if you only had maybe a database of 10 with 10 structures in, and you're only interested in one catchment that only had 10 barriers in, you could go through each of these structures in a GIS by hand, manually, and you could exclude and keep the points that you wanted, because there was only 10 points to have a look at. And in this case, it's quite obvious.
Oh dear. Josh, we didn't hear you for a moment. Is it only me, or did more people have that?
No.
Okay. Well, yeah, more people have that, I hear. So your connection is rather bad.
Okay, I will move closer to the internet.
Yes, please do so. And do you have your, you don't have your camera on, do you?
I do.
Yeah, let's switch that off. That might improve the sound as well. Okay. I hope that works.
Is that better?
I think so. Yeah, I think it sounds better now.
Okay, sorry, I live in the middle of nowhere, so I have okay. Where was I? So you can see these points because they are representing the same structure, and they're duplicating each other. They are clustered around a particular this dam, or one central coordinate in this case. Whereas non-duplicate structures are, because there's only one point for each of these structures in these two images, the points are randomly spaced and they are not clustered around a central coordinate. And in the left-hand image is actually a good example of what I was talking about earlier, in that we don't know if all barriers are recorded. In the left-hand image, I can see at least 4 structures, maybe 5 actually, which aren't recorded in this barrier database. So how can we use this information on how these points are structured to remove some of these duplicates automatically? So how can we maximize the amount of true data and minimize the amount of false data? So I'll come back to this graph in a minute, towards the end of the presentation. So we've devised a set of rules. So the first question we want to ask is the point located on the feature that is being duplicated? So there are 2 points, and both points are on the dam, or one point is on the dam and one is in the reservoir. We can say, yes, that's a duplicate, or no, and then we move on to the next step. And you follow these through, and if you apply this rule set to a sample of points that you've identified that are within a certain distance, so we chose 1,000 meters, you can start to apply these rules and manually check points to see if they are actually duplicates or not, according to your rules. And you can define your own rule set depending on how strict you want to be and how what you're interested in. Okay, so this is an example of some duplicates that our system flagged up. So using, you might not have to use the rules on the left, but Ian, could you please share the poll, and people can see if they can work out how many duplicates they can see in this image. Bear in mind that each point has a label in this image, so it's a bit of a trick.
You should be able to see it now, is that so?
I can see it.
Yes, people are responding now, yeah. It looks that most people are responding, yes, there are. No, it's half of people are saying there are 3, and the other half is saying there are 2. Although now more people think, yes, there are 2. That seems to be the most popular answer, although the other one, yes, there are 3, is also popular.
Okay.
Yeah, so that's increasing, yes. It's, yeah. Yes, there are 2, people think.
Okay, that's what people think. I can reveal that there are actually 3 in this image. There we are. So in this box, I've highlighted where the points which you might consider the duplicates. The red point is one. The pink dot is also another one, but that is actually where 2 points are located. So the unknown amber Balkan V4 and unknown amber HPP Balkan. This is essentially the same record that's been included in 2 databases, the exact same coordinates. So they're on top of each other. So in fact, there are 4 points representing this one structure if you include the point in the top left of the image. And as far as we're concerned, as long as we don't lose any height information or anything else that might be useful, we're not concerned which of these points we keep. So whether it's the point from the GRAND database or from the Danube ICPDR database, or one of the 2 Balkan databases, as long as we have 1 point for that dam, it doesn't really matter. So I've just highlighted those 3 in the middle, just because they're all together. Okay, so you do this, you repeat this for a number of points in your area of interest, and you then come up with a distance within which duplicates and non-duplicates occur. So the red line is represents the distance between duplicates and the point they're duplicating for non-duplicated features. So you can see, so this graph is indicative of the relationship, the spatial arrangement I described earlier, and the blue line is the distance for duplicate features. So you can choose a threshold at what cutoff point will I set to use to exclude duplicates. How confident do I want to be that my database is duplicate free? So, for instance, you could choose, I want to exclude 80% of the duplicates. So this will mean that you will very likely exclude 80% of the duplicates, but you will also exclude some of the non-duplicate structures. However, it is better to have a conservative estimate than an estimate which includes false positives. So in this example, you can see that 80%, I think in this case, works out at about 400 meters. So if you apply an exclusion radius of 400 meters, then you will exclude 80% of the duplicates. So to answer the question on the left, how duplicate free is duplicate free? Well, in this case, duplicate free means 80%. You could choose 100%, or you could maybe choose something lower if you really weren't that scrupulous. So in that last example, we sampled 200 points. So 200 potential duplicates, and then we applied the visual assessment criteria to those points. So how do we know that that's a good representative sample? So we resample that information, and we do that several thousand times in a bootstrap analysis. And you can see the black line is the median, and this example is Italy and Lithuania. And you can see actually after we sampled, in Italy's case, maybe less than 100 points, and in Lithuania, less than 40 points, the exclusion radius doesn't change. So along the x-axis, you have number of observed barriers, and the exclusion radius is on the y-axis. And the black line is the median rather, for those exclusion radiuses. And the grey just shows the confidence intervals and the variability in that estimate. So you can see with checking very few points, you can achieve a very high level of confidence in your exclusion radius, which is very useful when you're compiling a database like the one for Europe, where you have over 600,000 points that could be duplicates. So you've now got this duplicate-free database. How do you know you've got all the points in it? So in Europe, we walked over 2,500 kilometers of river, and we observed over 1,500 barriers. So lots of people who work in rivers are familiar with walkover surveys. So we walked all of these different stretches of river in Europe, and we observed all of the barriers to longitudinal connectivity that we came across. So how do we know that? So this looks like a very small amount of the river. So in fact, the total river network in Europe. So this is actually just less than 0.2% of the total river length, according to the ECRINS river network. So not very much. But actually, if you look at this graph, which is the number of river kilometers sampled along the x-axis and the new barrier density, so how many new barriers are we finding every kilometer? You can see that the black line is the median. So you can see after maybe less than 1,500 kilometers of river sampled, it stops changing. So that equates to less than about 0.1% of the total river length needs to be surveyed to get an accurate estimate of how many more barriers there are. So you can see after we did all of this surveying, we reckon we found that there was about I think it's 0.38 barriers per kilometer more barriers than there are in existing databases. So this is roughly double the amount of barriers that were in existing databases. An honourable mention here for our barrier tracker app. You can conduct these surveys with the app because it, as Barbara mentioned, it collects the same standardised barrier types and height information and other information that you need in a consistent database to perform this kind of comparison. So you could use the barrier tracker app. In fact, some of us used it in these surveys. Or if you're stuck at home because of COVID-19 lockdown, you can do it from home. So a colleague in Spain organised some volunteers to use a tool on our website, and you can see in just 7 days it went from the picture on the 21st of April to the picture on the right, which is the 29th of April, and they recorded something like almost 10,000 structures over the course of 7 days. Some of these we will already know about, but this is another tool for collecting additional validation data. And they'll talk more about the barrier tracker app and maybe this, well, certainly the barrier tracker app on the 15th of July, sorry, in the webinar that's happening then. Okay, so if you apply this sort of, we can then estimate sort of a barrier density. So this is an example from Britain. So using the data we gathered from existing databases, we can say that there's roughly one barrier every almost 4 kilometers of stream. However, we know from our validation efforts that there's possibly double this amount of barriers. So in reality, there's one barrier every 1.5 kilometers, and this is just in the UK, and the picture is very similar for the rest of Europe. Okay, so that information is useful, but it's can be very coarse and might not mean very much for fish or insects or plants living in river ecosystems. So how fragmented is the river? Oops, sorry, how am I doing for time? So how fragmented is the river? So we want to know how many kilometers of river are there between each barrier. So you can see that on the left you have an unfragmented river, it's 10 kilometers long, and then you put a barrier in the middle, and then you end up with two fragments. One is 3 kilometers, one is 7 kilometers. So this is what we've called a barrier-free length. So you now have two segments rather than one, and you have a segment of barrier-free length of 3 kilometers and 7 kilometers in each segment. Because we want to move away from passability, because passability is predominantly focused on fish movement and often only in one direction, and that is often upstream. So rivers are more than fish, certainly even more than the things that live in rivers, so it includes sediment and flow and lots of other things. So we want to get away from this idea of passability, because it unfortunately is very focused on one type of taxa. So we can apply this metric to somewhere like the UK, and we can see that it doesn't look very good. This map was created with only with weirs and dams, because that was the data that was most available in Britain. So looking at this, we can say that only about 3% of the river network in Britain is fully connected, and that's because there's a barrier in almost every single catchment, even with the existing data, even without adding all these additional barriers that we're aware of. But how do you calculate this sort of metric if your data looks like this? If you have barriers that aren't on river networks that aren't represented in your network, or barriers that are near the river network that you have, but you don't know which part of the stream they align to, you don't want to throw away this data, because clearly someone's put a lot of effort into collecting this data, and it would be a shame to waste it. So, fortunately, there's a relationship between the barrier-free length and density. So, this on the x-axis you have barrier density, and on the y-axis you have mean barrier-free length. So this is data for France and Britain. So you can see that quite nicely that the data follows this relationship. So what you can see is that, and this has been shown with other tools, which are far more complicated than barrier-free length. So the reason we chose barrier-free length, I should have said at the start, is that this is a basis for things like the dendritic connectivity index and lots of other indices that have been used to estimate fragmentation at catchment scales. And what you can see is that beyond a certain barrier density, you don't get very much, there is not much change in the barrier-free length as you increase the density. Similarly, if you were to decrease the density, it's not until you maybe go below 0.25 or 0.125 barriers per kilometre that you start to see a real change in the mean barrier-free length. And this picture doesn't change too much if you change the y-axis to a different measurement of barrier-free length. So you might say, well, what's the point if all of the rivers in Europe are heavily fragmented and all of the catchments have got more than one barrier every 4 kilometres, then we might as well not bother removing any barriers or even estimating the fragmentation, because they're so fragmented there's not a lot we can do about it. But this is just looking at France and the UK. 70% of the catchments already have, currently have a barrier density less than 0.25 barriers per kilometre. That is using the uncorrected barrier density, and the one on the top message should be changed to corrected threshold. So even if you apply the correction factor that we derived earlier on, that says actually there's far more barriers, then there's probably twice as many barriers, then that still leaves 40% of catchments with a barrier density that that we can, sorry, I've got this the wrong way around. If you increase the barrier density to 0.25 barriers per kilometre, then 40% of catchments are still good to go. So what I'm trying to say is that even though there's lots more barriers, there's still a lot of catchments, almost half of the catchments, certainly in Britain and France, that can be remediated because you stand a chance of improving the barrier-free length through barrier removal or some other restoration methods. So this is what the kind of data we could apply that relationship to in Europe. So if we take the data that we've collected so far, we can say that we have the picture on the left where barrier density is quite high in Central Europe. However, if we apply the field correction factor that we derived, we can see that there are far more barriers than we previously were aware of. But if we want to know at a strategic level where we can potentially do some restoration, and this links into the presentation which is being made this afternoon by Jessie Hanley, then there's certainly lots of areas in green which are suitable and for barrier restoration efforts. So that's my conclusions. So the first point links with Barbara very nicely, is that we can harmonize as much data as possible, and I will leave the rest of the points for a joint discussion later. Thank you very much.
Okay, thank you very much, Josh. So that was, I mean, we will go to questions in a minute, but I just realized that you said there's a lot of green where there's potential for restoration. But can you show that again? So there was not so much green as I could see, Josh, or did I not see that correctly? Can you show it again?
Yeah, I'm showing it now. Share screen.
So which green did you mean?
So by green, I mean this slide on the picture on the right hand side.
Yeah.
So obviously this is a very low level, low resolution image of what fragmentation is like at a regional scale. That the correction factors we used are based on a very small amount of information, and it will vary between catchments and subcatchments. But you can see certainly in, I'll just get rid of this, certainly in Scandinavia and the Balkans, in lots of places in France and Corsica, there are many places which are have a low enough barrier density that any immediate action would result in benefits very quickly.
Okay, okay. So it's very interesting. So and when when will we have the possibility to look in these more detailed maps of river catchment level?
So looking at a more detailed level will be once we've applied this relationship to these to this data, we will be able to address some of the EC's biodiversity strategy, where they would like to free up 25,000 kilometers of river. So we can then identify those catchments from a broader scale to say, well, out of these several thousand catchments in Europe, which ones can we look at in more detail?
Okay, so that gives a little bit of direction. Very interesting. Thank you, Josh. Sarah, did we have questions?
Oh, yes, we have we have questions, and I'm going to ask the questions as they came through. So also a bit from the previous session, but I know Barbara is still there, and I'm sure Josh can also answer this question. Basically, the question is there a disclaimer? This is from Polona. Is there a disclaimer connected to the database of barriers? Given that these are mostly public data, they should not be used for commercial purposes. Have you considered this, and how?
Barbara? When we asked for data to people, we agreed, so they agreed to share the data with us. When the data is within the AMBER Atlas, then you get a new unique ID. So it is part of our atlas that is going to be, as European Commission asked, is going to be used freely for research purposes. I don't know if I can go further with this question because I'm not really, I mean, Josh, if you want to complete about the part of.
Okay, so, but I mean, what you're saying, it is publicly available now, and there's no disclaimer at the moment that it cannot be used by commercial purposes, as far as I understand, right?
Yeah.
Okay, then the second question, this is for Josh, is from Ruta in Lithuania. She's saying, I was just looking at Atlas, amazing work. Thank you on behalf of everyone. I wonder if you can talk a bit about regions where there is not a lot of data or where a lot of barriers are categorized as other. For example, I'm from Lithuania, so I'm particularly interested in Lithuanian data. And is this a gap in national data collection? Will barrier ID card become a standard? Atlas has data only from national institutional databases. So this is actually two questions. So the second question is, Atlas has data only from national institutional databases, or it is a combination of citizen science data and institutional data? So the first question about the limitation and in places where there is less barriers, and the second question regarding, you know, the source of the data in the barrier atlas.
So I will answer as best I can, and then I think Barbara can also answer where some of the data comes from. So barriers were classified as other when their type did not fit one of the 6 categories that Barbara has described. And Barbara, please correct me if I'm wrong. We only collected data from included data where it was available. So, for instance, so much like Lithuania, in Italy, we only had a national database of dams, but only in a few regional regions in the north did we have complete or near complete information on smaller structures. So if the data is not available for parts of Lithuania, then we couldn't include it. But we're going forward, if we do update the atlas and update our estimates, in future work, now that we have this barrier ID card that we've described and the duplicate exclusion methods that I outlined, we can start to include more data from smaller organisations and individuals. But at the moment, the citizen science data is also a separate layer, so it's not included in that.
Then there is another question from Gonzalo. Could you elaborate on the limitations of the concept of passability, perhaps with an example in the context of the AMBER project?
So, passability is very, and in fact, I have a colleague who'd be even better to answer this. Passability is hugely variable, even within species. Just because one salmon or one trout has been observed to jump 2.8 meters over a structure, doesn't mean that every single salmon or trout can pass a structure which is that high, and also flow conditions, and there are a huge amount of other variables which affect passability at each structure. And quite often in passability assessments, small weak swimmers aren't considered. So particularly fish passes aren't built for species which are only a few centimeters long. And quite often fish don't fit into equations. So just because we've observed 20 trout in a lab can pass a certain structure, then doesn't mean that all trout will be able to pass that structure, because there will be variation within population.
If I may add, I think one of the most limitation of the concept of passability is that it refers to fish only, and river are more than fish. So we decided to move away from the concept of passability to have an ecosystem overview of the problem of river fragmentation.
So the next question, and this to Barbara, and it's from Polona again. So I recorded quite a few barriers with the barrier tracker that are not included in the atlas. Will this be made available eventually?
Maybe here I need help from the World Fish Migration Foundation colleague. So the data that are collected through the barrier tracker are not at the moment part of the atlas inventory from institutional dataset. These are not a different layer. So if your question was about that, I answered it, but if it was about if they are in the barrier tracker, I cannot reply.
Yes, so of course, the idea is that in the end, the data from citizen science would be included in the atlas, but we have chosen to have two different layers because the official information that is based on institutional data has been checked more thoroughly, and with the citizen science data that has been checked less thoroughly. That's the questions why there are two layers. We have used we have checked the data from the citizen science, you know, to see how it corresponds with institutional data. And we've also contacted people to find out more about these cases often. But they have not been included into the atlas yet. And that has been a decision after a lot of discussions that you need really a lot more data from citizen science before you are able to include it properly and into the atlas, and you would need more efforts to be sure that the citizen science is correct in the terms being used and etc. So that's why it is two layers.
it is also because the atlas is a static layer for now, whereas the citizen science data is alive. So in the future, why we will aim to join them, but yeah, for the
well,
moment.
and what's something that we will discuss on Wednesday, where we have presentations about barrier tracker, and where we look towards the future. And roughly spoken, it's very roughly, there are two possible futures for the barrier tracker. One is to be used more professionally for professionals who want to do registering the different barriers based on field studies, and the other one is more based on where are potential barriers that could maybe be removed. And I think these two types, what will be the final decision also defines the future of using that data into the atlas itself. So that will be a point of discussion on Wednesday morning.
Do you want any more questions, or do we still have time?
We still have time, yes.
I just wanted to add something to what you've mentioned. Just to make it clear, both databases, the ones that are from official data, which is the Barrier Atlas, the Barrier Atlas, they are available to download separately. So we can download the data corresponding to the Barrier Atlas, which is mainly from the official databases that we have, that we've collected. And then there is also available to download, and the data is there to be seen, from the citizen scientists. And we want, and this is a living, as it was mentioned by Barbara, this is a living citizen science project that will still be there, and it is going to be updated, and the more data we have. So it's almost like I'm requesting more people to do this and to walk the rivers and to use the barrier tracker app. So another question from Elena from Italy. Did you use regional databases in Italy? I'm particularly interested on the Eastern Alps basin, specifically on the Piave River. I don't know exactly how to pronounce the name of the river, in the Veneto region, which is the subject of my current PhD research. However, from the atlas, I can't see many berries as there are. Thank you.
I think, Barbara, I know that you have been diving a lot into that.
Yeah, so in Italy, we collected the regional databases, this is true, where they was easy accessible. Then we stopped to going too far in the data collection because it was not only our aim. And so I suggest you to ask to the competent institution there. So we don't have regional database in Veneto now, but probably you will be more lucky than us to collecting those data.
Do we have time for another question?
Yeah, I think so.
Thank you. Okay, so this is very good because we have questions from different countries, and this is exactly what we wanted. So we have now a question from Greece. Looks like Eurovision, actually. There are no rivers that you walked in. Sorry?
No, I'm just joking. 10 points for the good questions. Yeah.
Yes.
Anyway, sorry.
There are no rivers that you walked in Greece. Why is that? I guess this is for Barbara.
Yeah, when we designed the field validation across Europe, we tried at the beginning to cover area where we had also local national databases, and for Greece we hadn't. I think that Mauro Caroli is also here. So he was one of the colleagues that helped us in doing the field validation in the Balkan region. So maybe if he wants to add something, he's welcome. But yes, it was mainly a matter of we had to prioritize where to go, and the first priority was where we had data to check.
Hello everybody. I'm here. Yeah, we walked some rivers in Greece, mostly in northern Greece.
Okay.
So it was included in the Balkan area. I don't remember the names. I'm pretty sure that one was the Aliakmonas, coming down from the northern part of Greece. And I don't remember the names of the others. I can check.
Okay. Okay, maybe those were most questions, I guess. Let's move on now to the conclusions and recommendations. You had a slide for that, Josh. It was prepared by you and Barbara, I guess. Maybe we can check that now.
Yeah, hang on, I'll just get the slide from Barbara as well. Barbara, if you show your conclusion slide, is that okay? And then I'll show you.
I can do, okay. Just 1 second.
Meanwhile, if there are people who want to join this discussion, please be welcome and raise your hand, and we'll include you into the panel, so to say. It's very welcome if you want to discuss as well, like Mauro Garoli just did, for example. Okay, Barbara.
Okay, so
we go to your latest slide, I guess. Yeah,
we try to sum up some conclusions concerning the barrier inventory. So the main messages are all barriers have an impact on river fragmentation. So we do a call to make an effort to map all barriers. Now today we have tools for doing that. So you will, Josh presented some of them. You will discuss on Wednesday the barrier tracker. But also the message is for European members. We need to do an effort to improve existing database, to be able to combine them and to maintain this database, because I mean the Atlas also is something static, but it would be great if we can keep him alive to check, to monitor the status of river fragmentation in our rivers in the future. Again, Josh presented you the tools for combining existing information. We also defined this identity card that is simply a matter of few key variables that can be at least informed to make comparison and to make the big picture of the European scale. The second message, again, is to strengthen what I just said. We have to keep databases simple if you want to allow comparison and reuse of the data at the European scale. I mean, for our specific game, we can detail our database as much as we want, but at least we have to be sure that few key information are there. That is barrier location, barrier type, possibly allowing a translation in one of our 6-7 types. Barrier height is also extremely important for assessing the single barrier impact, and barrier age is important for future management. And that's all for my side. Josh, if you want to add something.
Yeah, so it's very important, as Barbara pointed out, that the data is kept simple, and so we can harmonize it all into a common format. So once we have this, we can produce these estimates of fragmentation, and where it comes from doesn't really matter. It doesn't matter if it's from a global database or from the barrier tracker app, or so whether it's citizens or whether it's governments or scientists. As long as we can verify that point is representative and those barriers exist, then we can use it. And combining databases doesn't need to be a problem. We've put a lot of work into Barbara and other colleagues have put a lot of effort into gathering data and putting it into the right format. But once you have even just the location of the points, we've found that actually it's not very much work to clean that data into and remove duplicates. And just as the source database isn't so important, it's not at a EU scale or even at a national scale. or even you could even operate at a catchment scale where you have lots of subcatchments. It's not crucial to begin with that your information is on barriers is aligned with the river network that you have. So if you were working in the River Thames in the UK and you had a river network that didn't match the barrier data you had, well, to begin with, that's not important, because you can just use the information you already have to kind of guide which parts of the catchment or country or region which are best suited for some further more detailed investigation. So you can identify where you can go in and do some more of the fine detailed work which might require you to align the data to the river network.
Yeah. Cool, thank you very much. I see, again, if there are people who want to join, maybe you, Polona, because I see you're quite active, would like to join us, or other people maybe want to join. I know that Polona asked a very good question. Polona, maybe you are live now, maybe you want to ask that question yourself.
Hello, thank you. Thanks everybody. For me it was very informative. I also know some of you already, and I think you've done a great job, and I just hope it will not end here. And so my question was, you've done all this work, but probably in the future more information will become available, especially from countries like Slovenia, which are lagging behind with their barrier assessments. And so who will be responsible to update the information in the barrier atlas? Do you have any future projects available? And yeah.
Yeah, at the moment, I can respond to that. At the moment, we are for sure that we keep the AMBER website and the barrier tracker alive for the coming year. We are now looking into how to finance also to make sure that it's a lot more than just a year, of course. And so that's going to be included in project proposals from Swansea University. And but for sure, at least you know, for the next year, we will be able to keep it alive. But I have good confidence, even if you look at also the interest that the subject gets now at the moment from European Commission or at member state level, that we will be able to keep it longer alive than that.
Okay, great. Yeah, because we're trying really hard to get some more information for Slovenia, and we'll keep sending it to you then, I guess.
Yes, you can send it to us, and that would be World Fish Migration Foundation, or via the AMBER website. There's also an email contact. You can contact via the AMBER website, and then.
Okay, great. Thank you.
Yeah. Yes, because I think this is a joint effort from many people, also including yourself, people watching now. We need to make sure that we keep this momentum going and keep on using this. Are there more people who would like to have some input or have questions on this issue, or on recommendations that have been made? If not, then I suggest that we are finishing this session 1 of the summer camp webinars of the AMBER project. Cesar, are you there? Because I'm asking because you were had to go away, I was told by yourself. If you're not there, then I suggest that we end with a song from our Eurovision contest. Eurovision is a contest that World Fish Migration Foundation is organizing, and we will end a song with that. Before we do that, then I want to thank everybody, and I hope to see you all at 2 o'clock. And for now, we will start with a song. Bas, our host, has chosen Save the Fish. It's a nice song that was sent in for this Eurovision contest. If you want to vote, by the way, for Eurovision, you can still do that. You can just type in Eurovision, and you can vote whether or not you like the song. Yes, Bas is showing the number of stars you can attach to that. So thanks a lot. Hope to see you at one of the other sessions in the coming days. And again, thank you, Cesar, in playing the guitar this morning. Thank you, Barbara. Thank you, Josh, for your good talks, and everybody who supported this. And hope to see you again. Thank you very much. Bas.